All right, last bit of new material before we can start talking about when our test is going to be. Okay, we got some more quadrilaterals to talk about. The next one's called a kite. Kite is just a quadrilateral with exactly two pairs of congruent consecutive sides, and this consecutive is important. It's not just any of the two sides are congruent, it's the two consecutive sides are going to be congruent. And there's exactly two pairs of congruent consecutive sides. Trapezoid. It's a quadrilateral with exactly one pair of parallel sides. With the trapezoid, it has one pair of parallel sides. Only one. What is the base of a trapezoid? The base of a trapezoid is each of the parallel sides of the trapezoid. So my trapezoid's got four sides. Only one pair of the sides is parallel to each other, and it's that pair that we call the bases of the trapezoid. All right, the legs are the non-parallel sides of the trapezoid. The legs of the trapezoid are the non-parallel sides of the trapezoid. Okay, what is a base angle of a trapezoid? A base angle, there are two consecutive angles whose common side is a base. And I've got pictures down below that might make this make more sense. So I've got two consecutive angles whose common side is a base. All right, and an isosceles trapezoid is a trapezoid with congruent legs. Okay. Oh, sorry, there's one more to talk about. The mid-segment of a trapezoid, it is a segment whose endpoints are the midpoints of the legs of a trapezoid. And again, I've got pictures down below that will demonstrate this better. Just make sure you've got all that down. Okay. First one. It says kites are quadrilaterals with perpendicular diagonals. So that's important. My kites, if I draw in the diagonals are going to be perpendicular, always. So what does that look like? There's my little picture. There's my kite. These are my two consecutive sides, so those are congruent. Two consecutive sides, those are congruent. My diagonals are perpendicular. Again, we have to remember that. Kites have perpendicular diagonals. All right, that little piece. Kites are quadrilaterals with exactly one pair of congruent opposite angles. So in between, so these are the ones that are going to be congruent to each other. So it's not the angles that are in between the congruent sides. It's these that have to be congruent. Now what is true about these, I've drawn another picture here. So in this picture again, these are going to be the congruent angles. What's true about these two angles is that the diagonal will bisect the angles. So be sure you've got that picture drawn. That'll help you out too. Okay, we go over here. Kites are quadrilateral with exactly two pairs of congruent consecutive sides. So that's all I did. Just marked it up, congruent sides, congruent sides. Okay, so hopefully this will make more sense as far as the trapezoid. So trapezoid there. So there's my trapezoid. These are my parallel sides, which means these are the bases. These are the parallel sides of the trapezoid, which means these are both the bases, which means these are the non-parallel sides, the ones going up and down here. So those are the legs. And so the base angles, I've got those down below. Hold on. So just make sure you've got that. Let's go here. An isosceles trapezoid. It's a trapezoid with congruent legs. So my legs will be congruent to each other. It's a trapezoid with my legs being congruent to each other. And isosceles trapezoids with two pairs of congruent base angles. So these are base angles because they're angles made using one of the bases. And these are also base angles because they're angles made using one of the bases. These two angles are congruent to each other, and these two angles are congruent to each other. And I got one last little picture here. Isosceles trapezoids are trapezoids with congruent diagonals. So if I draw in the diagonals AC and DB, AC has to be congruent to BD. This is only true of isosceles trapezoids, not just any trapezoid. It's got to be isosceles. All right. This was not on your paper. Be sure we get this in. This is called the trapezoid mid-segment theorem. So I drew my trapezoid. So trapezoid B, C, D, A. and then I drew in mid-segment XY. So a mid-segment goes from the midpoint of this side through the midpoint of this side. So I just called my mid-segment XY. And the way I can figure out how long XY is, so XY, the mid-segment, is half the sum of the two bases. So add up the two bases. So in this picture, I would add up the length of BC plus the length of AD multiplied by 1/2 or divide by 2, same thing, and that will be equal to XY, the mid-segment. Okay, so this is kind of important. So let's jump up here. Examples. How does this stuff really work in the problems that we're going to be doing? So it tells me I've got a kite. First thing I need to do is recognize if I've got a kite, my diagonals are perpendicular. So I draw in my little right angle right there. So the first question says, what's the measure of TWU? Well, TWU is right here. TWU, well, that's got to be 90 degrees. It told me already that TUW was 35, so I went ahead and put TUW as 35. And it tells me the WSV is 21, so I've already put in 21 there. Okay, W2U. WTU. Okay, well, if this is 90 and this is 35, this angle, the WTU, must be 55 to add up to 180 degrees. So that's an easy one. TUV, TUV. Okay, remember, TUV, this diagonal bisects this angle. So if TUW is 35, then WUV is also 35. So 35 plus 35 means TUV must be 70 degrees. Okay. SWV, SWV, well, that's got to be 90 degrees. SVW, SVW, same way I got it a while ago. Well, if this is 21, this is a right angle, this has to be 69 to add up to 180 for my triangle. And SVU, SVU, well, if this angle is 21, and this angle over here is 35, 21 plus 35, subtract from 180, that'll give me the SVU angle down here at the bottom. So again, it makes use of a lot of stuff that we've already talked about. Okay, yes, we need to recognize this one as an isosceles trapezoid. Trapezoid because these two sides are parallel, isosceles trapezoid because the legs are congruent to each other. So it tells me that XV is 4.6, XV, X to V is 4.6, and WY all the way across is 14.2. So YV, that must also be 4.6. This right here on top is an isosceles triangle. So if I know XV, then YV is the same. It's got to be 4.6. Okay, WV. WV has to be the whole length, which is 14.2, minus 4.6 to give us 9.6. XV all the way across, well, my diagonals are congruent, so if WY is 14.2, XZ must also be 14.2. And ZV's got to be the same as WV, which is 9.6. All right. We go to our trapezoid mid-segment. So we're trying to use our mid-segment theorem. So what's asking me for? It's asking me for KL. So it's asking me for the length of the mid-segment. Well, I know the two bases. One of them is 16, the other one's 26. The trapezoid mid-segment theorem says, well, to get the mid-segment, I can take 1/2 times the sum of the bases. So GH plus FJ. So I just plugged in. So KL must be equal to 1/2 of 16 plus 26, which is 1/2 of 42, which is just 21. So the mid-segment must be 21. This one sort of working a little bit backwards. Okay, so this one, we already know the mid-segment. The mid-segment is 23. We're trying to find the length of LP. We want this piece, so I just called it X here. This is the length we're after. Well, I'm going to use the same formula, that the mid-segment is equal to 1/2 the sum of the bases. But what is the mid-segment? It's 23. We already know it. So 23 has to be equal to 1/2 the sum of the bases. So the X, which is this base, plus 28, which is this base. So I'm going to multiply both sides by 1/2 to clear out that 1/2. Multiply both sides by 2 to clear out that 1/2. So that gives me 46 over here. 23 times 2 is 46. 1/2 times 2, those cancel each other out, so I'm just left with X plus 28. subtract 28 from both sides, and I get 18 is equal to x. And we said up here that the 18 was LP, so that's how we got the 18.